Welcome to the solutions to the Regents Physics Wave and Sound problem set, problems numbers 25, 26, and 28. Number 25, the speed of sound increases with temperature. Would the pitch of a closed pipe increase or decrease when the temperature of the air rises? Assume the length of the air column, the pipe, does not change. This is referring to the air column that's open at one end and closed at the other. And in that, at the fundamental frequency, a standing wave is produced equal to 1/4 of a standing wave in the length of the pipe. The key to this question is that the length of the air column is not going to change. Since the length of the air column at the fundamental frequency is equal to 1/4 of a wavelength, then the wavelength itself is equal to 4 times the length of the air column, and the L value is not going to change. If the L value isn't going to change, neither does lambda. So in our analysis of V equals F lambda, we're told the speed of sound increases with temperature, so our velocity goes up, our wavelength remains constant. Frequency and velocity then have a direct relationship as a result of that, and therefore the frequency must also go up. Human perception of frequency is pitch, so the pitch would go up. Two flutes are tuning up. If the conductor hears the beat frequency increasing, are the two flute frequencies getting closer together or farther apart? Well, as we learned in our lesson on beat frequency, an increase in beat frequency means that there's an increase in the difference between the frequencies of the two sources. This means the two flutes are getting more out of tune. They're not getting closer to being in tune, they're getting further out of tune. And the indication, of course, is that there's an increase in the beat frequency. And lastly, 28. One tuning fork has a 445 Hertz pitch. When a second fork is struck, beats occur with a frequency of 3 Hertz. What are the two possible frequencies of the second fork? Well, beat frequency means just that. It's the difference between the source of sound and the standard. So, if we have a 445 Hertz with a 3 Hertz beat frequency, that means the other fork has to be either plus or minus 3 Hertz. So the possible frequencies for the other fork are either 442 Hertz or 448 Hertz. That'll do it for numbers 25, 26, and 28. More to come in class tomorrow as we finish up the problem set with problems 24, 27, and 29 in class tomorrow.